All right, want to make sure you guys can hear me. Awesome. So thank you all for joining me. I know that it is morning of day 3, and I promise to not bore you guys. So I will tell you a little bit about myself before we get started. I'm Harley Green, Director of Business Development at Soft Robotics. I've been in the automation industry since 2003, really just focused on fluid power, sensors, safety, robotics. So I've seen a lot of good, bad, ugly, and I've seen a lot of ways that people have tried to solve problems. And what I'm going to show you today is a different way of solving problems that no one else has ever thought to do before, and in a very unique way that shouldn't feel that foreign, but enables a lot of new, really problems to be solved. So as long as this works. All right. So I'll start off by telling you a little bit about the company. We're founded in 2012. We are based just outside of Boston, Massachusetts, in Bedford. We are neighbors to a number of other robotics companies. Makes it really easy to get people on board that know a lot about robotics. We have about 60 employees at this point. We're constantly growing. I would say this week alone, we probably had another 4 or 5 hires. But we work with a lot of different manufacturers. We focus in the e-commerce, consumer goods, and food industries. We work with Fortune 500 companies. We work with Fortune 50 companies. We really try to help all these manufacturers solve problems. Number one being labor. Can't get labor. But as an organization, we're truly focused on gripping, vision, and AI. So when we talk about our automation solutions, the way that they're different from other solutions on the market are we're really enabling manufacturers to handle products that are variable, that need to be handled delicately, and that have irregular shapes to them. So if you think about in food, there's no 2 pieces of produce that are exactly the same. If you buy a garden pepper, you can buy a male, you can buy a female. They're short, they're long, they're fat, they're skinny. It's been a challenge, really, to handle those products historically. That is something that we have seen, we've gone after, and we've tackled that challenge. Irregular shapes. You talk about bags of product. So if you have potatoes in a bag and you try to handle that, one thing that people do really well is they can adapt to moving and shifting product. Normal robotics and grippers don't react so well to that. So we do really well when the product itself has an irregular shape to it. And again, we do a lot in food. If we're handling, say, donuts or Twinkies or whatever it might be, we don't want to damage or mark those in any way, because when it shows up to us as the consumer, it's not going to look good. We're not going to enjoy that. All right, so some of the challenges that the food industry in particular is facing, and what's really driving us to do what we do. So labor, talked about this before. Number one issue, it really doesn't matter what industry you're in, labor is a problem. Not only getting labor, but then retaining labor. One thing that I've actually heard from a number of people at the show, attendees, is they've had people come in the morning for a shift, they get trained up, and they're gone by the afternoon. So they just cannot get people into these facilities, and when they do, they just can't get them to stay. If any of you have ever been into a poultry facility, you'll know exactly what I mean. Beyond that, obviously everyone knows about COVID and every other virus that has popped up over the past few years. It makes it very challenging to fight through that and really manage your labor if you're a plant manager. Beyond that, you have the FDA, who is forcing stricter guidelines on food producers through the Food Safety Modernization Act, which is just making it even more challenging to stay compliant. There's also, the labor pool. There's not a lot of younger people that generally come into the industry that want to do this sort of work. Some might say millennials and Gen Z are, they feel entitled to not have to do those sort of jobs. So there's just this You have an older workforce in general that's in manufacturing, and they're getting the message too. They don't want to be doing those jobs anymore either. There's no low-cost labor centers in North America or really around the world at this point, so access to that labor is also a challenge. When we talk about our products and how we're solving problems, number one is our mGrip product line. mGrip, the M stands for modular. It's meant to be changed if needed. You can adapt this. It goes together like Legos. It is a food-grade gripper. We also make industrial versions of this. Now, this is really good at handling product, again, that has variability, irregular shapes, things of that nature. What we've done is we've actually taken that a step further. We've taken all the benefits of this soft grasping technology, and we've applied vision and AI on top of it. So not only are we able to handle a lot of variability like you typically see in manufacturing environments, but now we can see products, we can see piles of products, we can see that all in real time. So we take a look at what people do really well in these manufacturing environments. And again, people are really good at saying, I got to pick this up and I need to put it in this package. This product can come in any orientation, and if all of a sudden this product changes, it's a different color, it is a different shape, people are really good at recognizing that and adapting to those changes. Guess what? Robots haven't been historically. If you change one small thing with the robotic production line or an automation line, you sort of screw everything up. So I've seen this happen a number of times. You change a white part to a clear part, and all of a sudden you can't see it with vision anymore. So really what we've tried to do is we've tried to capture what people do really well in these manufacturing environments, and we've tried to apply that to robotics. Oop. Jumped ahead. So when we talk about our mGripAI solution, we've really taken the three elements of the hands, eyes, and brain, and we've now given that to robots in a new way that really tries to mimic what people do really well. So we have our perception module. So this is the eyes of our solution. This looks down into the robot's work area. This enables it to see the product as it's coming down the conveyor belt. Now we've also taken our iMod intelligence module. This does a lot of the processing. This is where all the AI and intelligence comes in. This gives us the ability to look at a whole bunch of product moving down a conveyor belt and individually see touching product, piled product, without having to singulate it, which is what you've typically had to do in the past. And then, again, we've afforded the human hand-like dexterity through our soft grippers as well. So again, really taking the value of our soft grippers and bringing it together with hands, eyes, and brain coordination. Just want to give you guys some examples of some products that we have worked with. Again, for us, we talk about food a lot. Food, there are three sub-segments that we focus on: baked goods, proteins, produce. You can imagine, you look at chicken pieces, chicken drumsticks, chicken breasts, they can come in all different shapes, sizes, they can look very different. When you get a pile of those coming down a conveyor, they look like one giant blob to a traditional vision system. What we can do is we can look at that pile as it's moving down a conveyor belt, and we can individually pick out each one of those. Now, in the baked goods space, we worked a lot of decorated product. We work with pastries, breads, things you don't want to damage or mark. We can handle these types of products at really high rates of speed, and I encourage you guys, if you've never seen a Delta robot before, they move insanely fast. Stop by our booth later. We'll show you guys a demo. But we can handle these types of products without damaging, marking them at really high rates of speed. Another sort of emerging trend is, I would say, much more in America than maybe Europe at this point, but these prepared foods or convenience foods. I know myself, I like to go to the freezer, take a frozen egg roll out of the freezer, toss it in the microwave or air fryer, and eat it a couple minutes later. And there's this emerging space in prepared foods or convenience foods that there's a huge market for. Now, the way that these products are produced are not so conducive to automation because they get fried, They're all jumbled up, and then they have to be singulated for a robot to historically have to pick those products and put them to a package. And then produce, like I mentioned, you're not going to get any two apples that are the same, any two avocados, whatever it might be. So really, just trying to give you guys an idea of the various products that we work with. One key important aspect for us really is the fact that customers, they want to make sure that they're checking these boxes. They want to be able to produce food that's high quality and safe. So both our grippers as well as our vision, our perception module, both of those are in the food contact area in a production line. They're both food grade, hygienic, and they're IP69K rated. So we use food grade components, stainless steel, food grade Delrin, but we also use a hygienic design. We use upward facing screws. We make sure that there's nothing or no areas for bacteria to collect or harbor. So again, really making sure that as a food producer, you're not concerned about anything getting into the product or anything from the environment getting into the components. So when we talk about the applications that we can focus on now, when you start looking at using vision in an automation line, again, historically you've had to singulate product upstream, but when you layer on AI and you look at a bunch of products that are coming down a conveyor that are touching or overlapping, that becomes a real challenge for traditional vision systems. So, we're looking at hot dogs on the screen. Those just touching might show up as one product, it might show up as 3 products, and it might just be one product. So historically, it's very challenging to handle products like that. Now, one thing that we found is there is just an absolutely enormous amount of cylindrical products that are produced in this world, but also if you think about produce, you got corn, you got zucchini, you got products like that. They have a tendency to roll when they're on a conveyor belt, right? What happens, even if you singulate these products and they're going to a robot and you've imaged that upstream of the robot, if it moves, the robot doesn't know about it. That's a huge problem. It results in you can't pick the product, you mispick the product, or you throw product. What we do is something very different. We're actually looking into the robot's work area. So as the robot is picking product and things are rolling around, we can handle that. I'll show you that a little bit more in a second. So touching or overlapping product is something that we can handle. Piled product. Now this is sort of unheard of. Sending piles of product down to a robot for the robot to pick, no one has ever done that, right? That's just crazy. People are really good at that. Robots are not. We can do it. You can send a pile of chicken drumsticks to a robot, and we can pick from the top down on this pile, and we can keep picking down and keep picking down and keep picking down because we can see the products underneath the top layer. And then we can actually take this all the way to 3D bin picking. So 3D bin picking, if you have something like peppers, or if you have buns that come in a tote and they have to be decanted and put on a production line, we can do that as well. So we're able to work with all different types of scenarios, all different types of environments and pick conditions. So how are we doing what we're doing? This is the critical piece right here. So we call this real-time picking and real-time object tracking, but we actually mount our perception module right over the robot's work area. So this is critical. If anything does change while the product is in the robot's work area, we realize it in real time and can adjust to it. So if the product moves, we know to not pick it while it's in motion, and then we can set new coordinates to then pick it. So again, game changer, makes it so that we can not only pick products when they move, but also pick piles of products. So again, you got that pile of chicken breast coming down the conveyor. We pick the top one off. We see the one underneath it, and now we can go pick that one as well. So we also do something that we call intelligent picking. In a lot of these prepared foods applications, there's a lot of sandwich building applications, and one thing that is very critical is determining, is this bun right side up or right side down? So again, people really good at looking at it, making a decision to either flip it and put it on the line. Robots, not so much. So what we can do is we can do in-bin sortation of the product. This is where machine learning and AI comes in. We can determine, is this right side up or right side down? And we can sort based off that. Now, we can take it another step further. We know everything about our grippers. We understand the fingers of the gripper, the dimensions of the gripper, the geometric configuration of the gripper. So we can actually choose how to best place the gripper to minimize interference with neighboring product. Again, a baked good. You don't want to damage your market. So for us, we make it really easy to go and do these type of applications without compromising the integrity of the surrounding product. So the way that we use machine learning in these types of applications is, in its most basic form, it's to identify individual products that are touching or in a pile and separate them from each other visually. We can actually, again, take that a step further. We can do classification of these products. So an application that we've come across a number of times over the years is building stoplight pepper packs. So you've got your red, you've got your green, you've got your yellow. In this pile here, we can take a look at that. We can actually individually segment those so that they're, again, each one of those are sort of its own little island. We can tell you what color it is. We can tell you how confident we are that it's that product. And we can even see the products underneath other products, even if they're occluded, even if there's only 10% of the product showing. And it's important to understand, we're not looking at a very small field of view or small area on a surface or conveyor belt here. We're talking like 2 by 3 feet on a conveyor, and we're looking at every single product on that picking surface, and we're making decisions in real time in a fraction of a second. Now, one thing that I've been holding off on telling you guys is, if it hasn't been clear, it's a 3D solution as well. So we are managing heights of the robot. Again, we know that we can pick from top down. So we're doing all this scene analysis within a fraction of a second. When we talk about other 3D bin picking technologies, we talk about other 3D vision technologies, in general, it takes seconds to process an image like that. We're doing it in a fraction of a second. So I'm going to get into some applications here to show you guys what we can do. Again, the name of the game for us is high speed. There is nothing produced in the food space that is not high speed. If you even look at the consumer goods space, everything is produced in mass at high speed. So we really focus on high speed. And this really plays into, you need the ability to handle the product at high speed. You need the ability to see the product at high speed. And you have to be able to react to changes in the environment at high rates of speed. So chicken drumsticks here. You see, this is very typical. When you are in a poultry production plant, you know, the process at the end is it has to be put into a tray or a thermoformer. The whole process upstream of that is chaos. Pieces are getting cut up, thrown all over the place. They come from different areas. They go up conveyors. They come down conveyors. And you get this jumbled mess that shows up at a tray pack station. Traditional vision and robotics, you can't handle that. There's no way that you can manage that. You would have to add in a bunch of equipment to singulate that product, adds in other layers of complexity, ties up floor space. Our solution can go right in line with the current process. So you can go right over the conveyor where humans are already doing tray packing. We can handle something like this, 55, 60 picks per minute. So if you think about that as a human operator, just picking these at 1 a second all day, every day, great job for a robot. So we've done a lot in handling brats as well. Again, this sort of plays into the, my God, there's so many cylindrical products out there. So brats, something that's very critical here when these are being put into trays, is you don't want to damage or mark the product. Right? Again, it all gets back to us as consumers. We want to have a repeatable product every single time we see it. We want to make sure that as these are coming out of a stuffer and getting dumped on a conveyor, that when we go to pick the product, that we're not damaging the product that we're picking or marking it, but we're also not damaging or marking neighboring products to it, so the products that are around it. So we have a unique gripping solution for handling this type of product, but coupled with, again, our machine learning and AI, we can individually see these as they're touching each other, as they're layered over each other. All right, so again, another cylindrical product. Hot dogs. Hot dogs, Americans eat an absolutely enormous amount of hot dogs. You go to any baseball game, you're eating hot dogs. For us, if that video plays, great. We can handle these at very high rates of speed. If these are frozen, you're talking 80, 90 picks per minute with the robot. Think about what 90 picks per minute sounds like, right? 90 picks per minute is 1.5 picks per second. Imagine doing that as a person, moving your arm back and forth 90 times a minute. Insanely fast. But we can handle piles like this of product. This is not atypical. This is very typical in a lot of these applications where, again, people are really good. They can handle piles of product. Robots can't. Traditional machine vision can't. So what we've done is we've unlocked the ability to drop in a solution right over the area where human operators were before. All right, chicken drumsticks. Slightly different chicken application. This will show you a little bit about how we individually segment the product, how we sort of isolate one from all the other products. But for us, video's a little choppy, but we can handle something like chicken drumsticks 70, 80 plus picks per minute, right? So just think about that. There are human operators that are doing these tasks currently in these really nasty, cold, wet environments. We can take them out of those roles. We can have them add more value in other ways in these production environments. This is a cylindrical product. A product like taquitos, right? These are one of those snack foods, one of those prepared foods. I know I eat an absolute boatload of these, but they have a tendency to roll around, right? These come out of in general, they get fried, they go through a freezing process, then they get dumped out in random orientations on a conveyor belt. Well, trying to manage that and get these things singulated is one challenge, but doing that without damaging the product or knocking off any blisters, any of those fry blisters on the product is incredibly important. The more you transfer the product, the more that it has to go through the singulation process for traditional systems, the more chance there is for product to get damaged. So for us, we can pick the product, we can singulate at high rates of speed, or we can go directly from sort of this chaotic mess to packaging. And then again, we can also handle the product if it is already singulated. So something like taquitos, we can handle 90, 100 picks per minute. All right, so corn. The corn industry, huge. Everyone, especially this time of year, is eating corn. It has to end up in a pack typically, right? So you'll see lines of workers where you've got 20 people at the end of a line just taking corn that has been dehusked, cut, and it just needs to be put in a tray. And it's just a very tedious, ergonomically challenging task for these operators. We can handle corn at anywhere from 70, 80 plus picks per minute. We can get them into those trays the right way every single time. For us, you can literally just send this down a conveyor belt, random orientation, touching product, overlapping, and we can handle that. When we talk about consumer goods, right? A lot of these sort of order fulfillment applications, you might end up with a homogeneous bin of product, you might end up with a segmented bin, or you might have to manage returns for all intents and purposes. So we have the ability, because we can utilize machine learning, we can understand the orientation of the products, we can understand and classify each of the different products that are in this tote, and then we can sort based on whatever we need to for that application. Now, when we talk about bin picking, generally robots move a little bit slower. You're going to have to use a different type of robot so that you can actually get into the corners of that tote. But we're doing bin picking at anywhere from 20 to 25 picks per minute. All right, so just want to sort of wrap this up for you guys. The value that we can bring, if you're an end user, right? We unlocked a different way to solve your problems. If someone told you they couldn't do this in the past, whether you didn't have enough floor space for simulation equipment or it's too challenging to do the vision piece of it, we can do that now. We can help you through that process. If you're an integrator or you're an OEM, if you have these projects, we can help you there, right? You now have another tool in your toolbox to go after and solve these problems in a different way. So we offer this all-in-one integrated solution. If you've ever had to make different pieces and components talk to each other, sometimes it's a nightmare. We take care of all the work up front for you on that. So we bring the hands, eyes, and brain together in a single solution. We enable you to reduce the overall footprint of your system, right? This is critical. I can't tell you how many times I hear this every single day from customers. I want to do this, but there isn't enough, floor space. I'm trying to fit a square peg into a round hole. How can I do this? This is a great way to do it, right? You don't need to add in a bunch of additional equipment. We always talk about, in food in particular, you have to have a food grade solution, right? IP69K is a requirement if you're going into any primary food handling application. We're IP69K rated. You don't have to worry about that. You can use our solution in really any environment without worrying about if there's going to be any issue with it. Because we do all the machine learning on our side, by the time you get a system, all you have to do, power it up, and you can start picking product. And I would say one of the most critical pieces, again, in the M in mGrip, and mGripAI stands for modular. If something changes, if the product changes, if you have a flex line that you're trying to run, and you want to run a different product down this line, it's as simple as you may change out your gripper to a new gripper, you upload a new machine learning model, and you hit go. So we call that being flexibly deployed. You can easily change your line to whatever you might need it to be. And with that, I'll open it up to questions and answers. Again, my goal for today was really to give you guys an idea of this technology. We launched this product, I would say, a little over a year ago, and it was really, we're trying to bridge the gap in a lot of the technologies that are available for robotic automation.